EMF of cell is 6 volt, and 3 resistors are there, they're in series. So each resistor having 2 ohm. Then the earthing is at this point. Then what is the expression for current? So let me apply the KVL. Plus 6 minus 2i minus 2i minus 2i equals 0. So I is equal to how much it is? 6 by 6, 1 ampere. That only it is written here. I equal to E by 3R. Again applying KVL. Plus 6 minus 2i. The resistance is 2 ohm. No? 2i minus 2i equals 0. Solving then you'll get 1 ampere. Or plus E minus IR minus IR minus IR. Solve it, you'll get the same answer. Okay, some are getting confusion. I'll show by other thing. In terms of symbol, I'll show it. Hope you are able to understand now. So what is I is equal to E by 3R. Why negative sign? Current enters positive, it leaves negative. Okay, I got the current. Okay, now let me define what is the potential. Like if you earth, that particular potential of that should be 0. This is like a earthing. We did earthing. Look at this part. Huh? We did earthing, no? Then, okay, let's potential of that point must be 0. When you earth it, a point in circuit, the potential of that point where it is earthed, there should be 0. Then we'll write potential difference VA minus 2I minus VG 0. Then we are able to define absolute potential at a point, 2 volt. Similarly, I want potential of point C. VG minus IR minus 2I minus VC 0. I'll solve for VC. I'll get minus 1 volt. So what is the absolute potential at point C? Minus 1 volt. Similarly, I want potential at point B. VG. So what is the method again? VG minus IR minus VB equals 0. How I got it? I'll write equation. Huh? Solving this. VG minus IR minus IR. Resistance is how much? 2 ohm. So solving this, I'll get the VB equal to minus 4 volt. So what we are able to do, we are able to define the absolute potentials in a circuit. If you have a thing, if you remove earth here, then we can define only potential difference. So by earthing what we can define absolute potentials. By earthing, a point in a circuit, we can define absolute potential. There's a major idea. Okay, no student, now so it can happen. The earthing what happened, I'll shift it to some other point. Then what will the current? The current same 1 ampere will flow. Nothing will happen to distribution of current when you change the earth point in a circuit. The same 1 ampere will flow. Are you looking at this? The same 1 ampere. So again, write loop equation. So what is the loop equation says? I'll solve it here. Plus E minus IR I is equal to E by 3R. Okay, the same thing. Okay, after getting this, now define potential at point A. VA minus 2I minus VC 0. Solve it, you'll get 4 volt. What was the earlier potential? 2 volt. So by varying earth, what happened? The current in the circuit remains same, but the absolute potentials at various points will change. Earlier, what was the potential when earth was at point G? The potential of point A was 2 volt. Now, what is the potential of point A? Is 4 volt. Potential of point C will be 0. Other potential of point C was -1 volt. So by varying earthing point in a network, current distribution of a network will not change, but in fact, the absolute potentials will change. Okay, how it will become VA 4 volt? Okay, again the loop equation. VA minus 2I, R is the resistance 2 ohm, no? Minus 2I minus VC 0. Okay, like this, we can write